Now in today's class, we'll start with the concept of file systems. So in general, if you have certain information, where you will save that information, how you will save that information? General in the form of a file, which I can say that file is simply a collection of related data. Technical I can speak, right? If I say, if you would like to represent something in the form of a picture is also file, which contains certain related data, right? If I take any kind of class data, something like it can be CSC 3 and CSC 4 data, or it can be a kind of data which is related to the CS department. Right? Anything which is related to the some location, I can call it as a simply a file, right? So these files in general can be extended with various types. Am I right? Can you give us certain examples? Various types of files. It can be any kind of PDF file which can be extended. It can be .exe file. It can be .obj file. .class file. Hope you got the idea, right? Which you are using the Java. It can be .jpg. It can be .png or .doc, etc. Various kind of other format of files are there. They are going to be specifically used for specific purposes, right? If you would like to store some text data, then I can go with the doc format, right? If you would like to store some text data along with images and I should not edit that, then I can go with the PDF format, right? Like that, various kind of advantages are there with each and every kind of extension I can call, right? These are the various types of files that are available for us, right? And these types of files can be understood by the operating system directly based upon the extension. Based upon the extension what we extended, operating system can able to understood it, right? So simply file is nothing but a collection of related data, right? So if you collectively collect them all the files, I can call it as a directory, right? If you open in your system, you can observe one directory which contains a collection of files. Those files can be again any kind of files. It can be images, it can be doc, it can be video, audio, or PDF, whatever it might be, right? Fine. And this collection of directories, I can call it as file system, right? So simply we can say file system is nothing but a collection of directories where I can store huge data. One directory will contain subdirectory. That subdirectory can contain any kind of data, or it in contains any kind of directories also, right? So if you talk about technically, file system is a kind of a software. That is part of operating system, which is used to manage and create various directories, right? Hope you understood the definition, which is a kind of a simple software, which with that software I can able to create the directory, I can able to delete the directory, I can able to perform any kind of operations on the directory, right? So without this software, it couldn't possible to interact with the system, right? OS is also software. In that, file system is one kind of software. With that, I can able to perform various kind of operations. Simply, I can say this is a kind of a GUI, graphical user interface, right? Directory is one kind of an interface where I can able to interact with it, right? So file system is meant for generally used for to work with a file. Here file means a directory also file, right? So file means it's not only a kind of a file, directory also I can call it as a simply a file, right? So the main reason why we are studying this file systems concept is how you are managing the files, how you are going to manage the files, and how you are going to organize the data in secondary storage devices. To make this, we are trying to study the concept of file systems. Means at the end of the 6th unit, we are able to know what is the interface of the files, how the files are organized, and these files how internally store in the secondary storage devices, right? How we are going to store, how we are going to allocate the memory, all those things you will let you know, right? So basically, if you broadly categorize these file systems work, it can be categorized into two parts. One will be file system interface, another part will be file system implementation. See, I am not going to tell anything extra thing here. File system work can be broadly categorized into two parts. One is, in general, in our terminal, if I say front end part and back end part. What is the front end part? User interface. That is what? File system interface. And back end part is nothing but we don't know exactly how it is internally working, but by simply understanding the file system implementation, we will let you know that how internally file system is working, right? Fine. So simply file system interface provides an abstraction for you, an abstraction how user will interact with the files, how user will interact with the files, and we no need to worry about how they are going to be stored. We no need to worry about how they are going to be stored. That will be defined by the file system interface, right? As an end user, if you go with any kind of web application, it contains majorly two parts. One is a front end part, another one will be back end part, right? In front end part, only user interface will work, right? And when you are going to give or hand over this web application to any kind of user one, he will always trying to work with the front end only, right? He is not bothering about how in the back end it is working, right? So if you want to know how the front end is working, the same kind of thing, to understand how the file system user is going to interact, I don't need to worry about the internal working. That will be defined by the file system interface, right? So simply we are going to know what are files, what are directories, what are the attributes of the files, what are the operations of the files, how we are going to access the files. All these things we will let you know in the concept of file system interface, right? It's a kind of only front end part. Coming to the back end part, like how these files are going to be stored. For that, we are going to learn the concepts of how files are allocated. We can say that file allocation methods. How we are going to manage the free space. How you are going to move from one place to another place. For that, we are going to apply in a concept called disk scheduling. So you are going to learn these three kind of concepts in the file system implementation. Okay, now see, I haven't covered any kind of concept. I am just letting you know that what are the things that will become under file system interface and what are the things that will become under file system implementation. Okay, is it okay with everyone so far? Right, so just I have explained what is a file and what is a directory, and this collection of directories I can call it as a file system. So can you tell, for every operating system, does it exist a file system? Yes or no? Yes, definitely. There are some systems, can we install multiple operating systems? Yes or no? Like you might install Ubuntu and you might install Windows, like that you are going to install, right? Then the data which is present in the operating system is different from one operating system to another operating system or not? Then how many file system will exist in the system? Two file system, right? Which means that if you take any kind of a computer, if more than one operating system exists, then how many file systems are going to be existed? More than one file system is going to be existed, because the data which you are trying to store will be organized by file system, right? So each and every operating system will have certain file system which is capable of managing all the files in the system. Okay. So if you take any kind of a file, can I call directories also file? Right? Anything that technically call it as a file, that's it, right? So something like any kind of a file. So can I call this as a file? Right? So if you go with the directory, one file if you take, you can call it as a file. For that file, you can have certain kind of properties. Am I right? Properties means some kind of additional features, right? By looking into the properties of file, you can know that various kind of additional features, right? I can say something like metadata about the file, right? If I say a student, I don't know exactly who is the student, but if I give more elaborate information, means data about the data, a student data, then I can get the properties, right? So properties are, I can call them as attributes. These attributes will provide extra information. Okay. And any other things will be existed? Operations. Right? So it's a kind of a concept which is related to the real world only, right? If I take in Java, if I say a class is a kind of logical entity which is a collection of what? Data members and and functions. Functions are nothing but methods. What are data members? Attributes. What are methods? Operations. I mean, in the real world, if you take anything, everything is going to exist with one is properties and with certain operations. Right? If you take human being can have age, height, weight, color, like that. And what he will do? He can sleep, eat, like that, right? So similarly, if you take any kind of a file, it can have certain properties and certain kind of operations. So what might be the properties exist? Can you tell? Hope you know, right? Very good. So before that, it's better to go with name of the file. First thing, the basic criteria, right? So name of the file and size of the file. What is the type of the file? What is the type of the file? So I can say simply what it is extended with, .pdf or .jpg, like that, and what type of content it contains, whether it is mp3 or video, like that. Inner things, it can have path, right? Path, good. So I can call it as location or path. Have you observed anything? Right? If I take anything, so just right click with this and you can observe the properties. Properties are nothing but all the things, right? Like location, size, cyan, that is contains, created date, attributes, sharing permissions, all those things, right? These are all will be comes under the properties of the file, right? So location is one thing we observe, and protection. Who might be access to this particular file, whether it is having read permission, write permission, or if you look into the point of date and time, right? Who will be created, on what time it has created, on what date it has created, or so root one is one person is there, and there might be some person who might be modified later part. So we can call it as modified date. Is it true or not? Yes. And something like who is the owner of the file, etc. These are all the various kind of properties that you can observe with respect to a file. Okay. And what might be the operations that you can perform over the file? So obviously we can able to create a file, first and foremost one. After creating the file, if you want to do something, first what you have to do? You have to open the file. Then can you write something on the content? Right? Then can you perform save? And then I will close it. Again I will open it, and then I will append some data. Then I will try to perform some save as. See, this is a kind of a file. If I click all these options, I am trying to write. Right? So save as, or something like if you take any kind of text file, I can able to perform truncate operation. Truncate means I will delete the data but not the actual file. Right? Only content is going to be deleted but not the file. Right? That is what we call as truncate. Can we perform rename? Can we perform delete operation? Right? And you can able to perform copy, cut, paste, and something like print, etc. If you are able to write, many things will be existed. So these are all the things that will be comes under operations of the file. Right? So anything explanation required about here? These are the general things. Only I think truncate means we are going to remove the content, but not the file. Right? In SQL also it is, you observe this terminology, right? There is a difference between the delete and truncate. Delete means which will delete the data as well as delete the file. Whereas coming to truncate, which will only delete the content but not the file. So once you know about the properties of file and the operations of the file, then you might get the question how we are going to access the file. Right? So in order to access the file, what are the things that you required for you? Right? I am trying to say that please access jk.doc file. Then what is the first question that you will raise? In which location? Right? So means if you want to access the file, first and foremost requirement is in which location the file is existed. Right? Even you know location of the file, if it doesn't have any permissions, can you able to access it? No, right? So then you have to know what are the access rights. These are the two things that minimum required. Then you have to have a file pointer. File pointer is meant for what? Either for reading or writing. When you open a file, like if you look into Java, right? You have the concept of files, right? Where if you want to access the data, how you are going to access the data? Byte by byte, right? Character by character, right? So the pointer is moving from one location to another location. As it is moving from one location to another location, you are going to access the data, right? Similarly, if you want to access the content of the file, definitely you require file pointer, which is meant for to read as well as write. Again, if you say in depth, there will be a read pointer and there will be a write pointer. Read pointer is pointing to the location where user is trying to read the data. Write pointer is pointing to the location where user is trying to modify the data. And one more thing you required is file open counter. These are the four things that you required in order to access the file. Right? So in general, everything will be maintained in terms of tables. Operating system, everything is going to maintain in terms of tables. Let us say there will be a file called jk.c. Something like file name. How it will be maintained means For this, they will maintain file pointer. They will maintain file pointer, and then they will maintain access rights. Access right, which means that for every user operation, I can say it as for every user process, operating system will maintain per process table. Right? In the last class, I mentioned when you are going to have a process, this process is going to be split into multiple parts, and in order to connect this with the main memory, it is going to maintain what? Page table, which is meant for the conversion from logical address to physical address. Similarly, for any kind of a user process, separately it will maintain one per process table. Why it is required? It contains various information. What is the file name? For this file name, what is the lastly user is user is pointed location, file pointed location, and what are the rights? Whether it is having the read permission, or write permission, or R place, write place, like that. Right? And along with this per process table, operating system will maintain one global process table. Again, which contains the file name. Right? If you want to connect two tables, definitely you require one common thing, file name, and which contains now file location, and file open count. Right? Which means that for every user process, two tables will be maintained per process table, which is individually maintained for each and every process, and for all the process there will be one common table, we can call it as global process table, which contains information file name followed with the location of the file followed with the file open counter. So hope you understood the what is file pointer and the access rights and the file location and the file name. So what is the meaning of file open counter means? How many times can we open the file in the system? N number of times. You can able to open the file n number of times, as much as like memory is enough, right? So file open counter will maintain the counting, how many times the file is opened. If I say 2, jk.c file is opened for 2 times now, 2 times, right? Based on the opening and closing of the file, this file open counter is going to be increased as well as decreased. Right? Whenever this value is going to be decreased to 0, then that particular file is going to be removed from the cache memory. Right? This is the way how it will work. And global process table is going to grow and or shrink as per the user working. Right? When user is opening the files, many files, it will grow up the global process table. When user is closing the files, it will shrink the process tables. Fine. So when everything is going to be perfect, right? So he has the file pointer, he has the access rights, and his file open counter is incremented by 1, something like that. Then how he can access the data? My question is, we have n number of files. How he can access those files? Right? Whether he can able to access the files in terms of sequential manner, right? So means he can able to access the files in sequential wise, or he can able to access the files in a random fashion. Random fashion means what? Simply going blindly and pick up one file, or we can go with the indexed access, indexed way of accessing, right? Means once they have specific access rights, how they can access the files? They can access either sequentially. What is the meaning of it? Presently I am at this location, assume. right? From this location I can move to certain file, another location. From this file I can move to another location. This is what we can call as sequential, moving continuously from one location to another location, right? And I can go with randomly. See, if you go with this one, right, this is a kind of directory is also file. Now resource is one kind of file. If I double click here, I can move to get question folks, something like that I can move, right? This is what we call as a sequential way of accessing, right? And some other kind of accessing, that is random accessing. What is the meaning of random accessing? If I go with directly clicking on 15, right, I will directly go with certain location. That is what random accessing, random accessing. And another kind of accessing is we call it as indexed way of accessing, right? What is the meaning of indexed way of accessing? Right, here also we will jump from one location to another location, directly, but with respect to a particular file, right? If you open any book, first what you will do, if you want to go for a particular location, first we will go with the index page. Once you go with the index page, then only you can jump to the respective location, exact location, but it couldn't possible without the index location. That is what we can call it as index way of access. These are the three ways that you can able to access. One is a sequential way, random way, and the indexed way. Okay. Have you understood? Right? Fine. So as per earlier explanation, if a computer having more than one operating system, it can have definitely more than one file system, right? Let us say it might be Windows file system. Have you understood the technical terminologies? Anybody remember? What is the file system name that Windows is using? I didn't remember exactly. If you remember this terminology, NTFS. Anyone? Exactly. This abbreviately we call it as New Technology File System, if I am not wrong, right? So like that, for every file system they come up with some new names, right? So in a computer, if more than one operating system is going to be existed, more than one file system is definitely going to maintain, because the data what is present in the Windows operating system is different from the data present in Ubuntu operating system. That might be various reasons again. Windows operating system is used by user 1 and Ubuntu is used by user 2. Anyhow, at the end, these are all going to be maintained by what? One hard disk. One hard disk, right? So which means that the entire data they are going to be maintained in the form of one directory. In the form of a directory, we can call this as special directory. Special directory which contains all the information. So as I am saying that this is a directory, this is what we call it as directory name, and it can be partitioned into many parts. This is a part which is related to Windows file system. This is a part which is related to Ubuntu file system. Ubuntu file system, and this each and every part we call it as a partition, or I can call it as mini disk, right? The main disk I am trying to split into multiple parts, where each and every individual part I can call it as mini disk count, right? And if you look into this particular directory properties, which contains various kind of information again. What might be that information? What is the file system name? What is file system name? And what is the starting address of the file system? And what is the ending address of file system? If I say, like for the sake of our understandability, Windows file system is occupying the hard disk, is occupying the disk from 100th location to 2000 location, and Ubuntu file system is occupying from 2001 to 5000. Like that, it is going to maintain here, right? So it's a kind of a directory, right? It's a kind of single directory which can maintain all the information. But in general, how much data are you going to have? Huge data. Trying to perform certain operations, that might be searching operation. Searching is one kind of operation, right? Like, I mean, on this particular directory, you can able to perform various kind of operations. What might be the operations you can perform? Can you perform search? Right? So, if I say this is directory, I can be able to perform the search. Right? Search options there. But the directory is a huge directory, some 1 TB of data. When you try to perform search operation, how much time it is going to take? It is going to take more time, right? So similarly, if you want to perform any other kind of operations, it might take some difficult operation, right? For that reason, what I will do now, I will try to split the directory into multiple parts, or I will try to place the directory in some kind of hierarchy manner, right? Something like a root directory, followed by subdirectory, followed by subdirectory, so that trying to search is easy or not, yes, right? Fine. So before that, what might be the operation that we can able to perform on the directories? We can perform search, right? Can we able to create the directory? Can we able to delete the directory? Can we able to traverse from one location to another location? And can we able to rename the directory, etc., right? See, what are the things that I have written earlier, all those things I can able to do here also, except writing like that. Writing right? Writing can be performed only in the files, but not in directories. Directories are meant for only grouping the related files, right? So these are some of the operations that we can able to perform on the directories. Okay, now fine. So in order to eliminate this difficulty of searching or managing the collection of files, I am going to simply maintain these directories in the form of some hierarchy. Then I can call it as levels of directories. So basically, so far we discussed with what kind of directory? Single level directory. In single level directory, there will be only one root directory. Which contains various kind of files. See, many textbooks are going to represent the directory symbol in such a way that rectangle will follow, and this is what they are saying, that it is a file. That's it. There is no specific meaning. Directories were going to represent in the form of rectangles, and files were going to represent in the form of some circle shape, right? Fine. So these are what we call it as file. That's it. Single level directory means there will be only one directory which contains all the files. Now, in this kind of approach, what might be the problems that you are going to face? Good. First and foremost thing will be, search will be difficult. Right? Are we doing the searching, or system will do the search? System will do the search, right? Then how it will be difficult for the system to search? As it is a huge data, trying to start searching will take more time, right? So as it is taking the more time to search, that's why I am saying that searching will be very difficult. Anything that you observe, the drawbacks that will become under the single level directory, right? If I am going to have a directory, can I have any other file with the same name? No, it couldn't possible, right? So there might be getting a chance of naming conflicts. Right? You should not save two files with the same name. This is one problem that you can face. Any other things? In point 1, restriction will be difficult, right? So when you go with some kind of data, like you have a single folder, the same folder you are going to maintain your work folder as well as your family pics. Let us say, if you give it to your kid, what they will do? They might delete the work related information also, right? That is where you might lose entire data. So giving restrictions will be difficult when you are going to maintain with a single level directory. So to overcome these drawback, we are going to go with the multi-level directories. What might be the advantage of single level directory? Simple point, which is very simple to implement or which is simple to manage. If you go with the multi-level directory, how we are going to maintain the data? So multi-level means it can be more than one directory. It's like it can be a 2-level directory, 3-level or n-level directory. Something like this is a kind of a root directory. This directory contains, let us say, there will be a file. Same level it can contain a file. This contains a subdirectory. This also contains. Better to write all in the same level so that you can avoid the confusion. Same level. So this is what we called as 2-level directory. Now it contains all the files. Right? If you want, you can go with the 3-level directory also. Again, it will be divided, something like this. This is what we called as multi-level directory. Right? Then, are you going to overcome all the 3 problems here? Searching will be difficult. Is it reduced or not here? Yes, definitely we can reduce it, right? Which means if I want to search the data which related to work only, then I will go with the location where work folder I can search it, so that which will definitely take less time compared to single level directory. Similarly, naming conflicts, right? When we have more than one directory file contains the same name. See, can I save here the file with the extension jk.c? And can I save in the work folder file with the name jk.c? Yes or no? Because those are 2 different directories. So naming conflicts also going to overcome. Can I restrict one folder? Yes. I can make lock to this folder. So that this folder cannot be opened by anyone, but these folders can be opened by anyone. So like that, these are all the drawbacks that can be overcome by multi-level directories. But here there will be one concern. That will be if one drawback will be implementation is going to be difficult one. Obviously, right? Implementation is difficult compared to single level directory. That's one thing. Suppose for example, just now observe, there will be a file jk.c is available in 2 locations now. Like something like a duplicate. If I am going to modify something in the jk.c file, will it be updated here? No. Then there will be the problem is data anomaly problem. Right? So there will be 2 same files, but one file contains certain data, another file contains some modified data, which is not the correct one. Right? So for that reason, to overcome that drawback, we are going to go with another kind of directory mechanism, acyclic graph directories. In acyclic graph directories, these systems will follow file sharing approach. Instead of maintaining the entire copy of data into the separate location, they will just make sharing it. So that if a particular file is updated, something like jk.c at one location, as the other location also pointed to this one, this location also automatically updated. If one file is updated, automatically the other file is also updated. This kind of directory mechanism we call it as acyclic graph directory approach. But again, here also there will be some problem. What is that? Okay, implementation is difficult only. Fine. Any other things? If I delete jk.c file, which I thought that which is not important for me, for the user one. What about for the user 2? It is also deleted. Then it will be lost. It will be lost, right? So this is the one concern that you have to understood here. Means if file 1 is deleted by user 1 and user 2 is already pointed to file 1, then definitely there you will get the concept of dangling point. What is the meaning of dangling pointer? Which is pointed to a location where data is not at all available. We call it as dangling pointer, right? And one more thing that you have to observe, same file can have, this is not that much problem, but you have to make it concern. Same file can have different paths. Simple can have different paths. So these are two concepts that you have to make it clear. Right? Have you understood why we move for the concept of levels of directories? Right? If I say that there will be a huge data, right? Trying to work with a huge data in a single location will be complex for anyone. That's the reason we are going to go with the levels of directories, where you can observe single level directory or multi-level directory, or I can go with the acyclic graph directories. Okay. Fine. So how we are going to create the directories, ma? How we are going to create the directories? Using file system. Right? File system is responsible for everything. Right? File system can manage everything. Fine. So file system is something like a kind of GUI. Right? It's a kind of GUI. Now, if I say there will be a computer, which contains operating system will contain a file system. Now if you want to create the directory, or if you want to create one file, or if you want to write certain data, definitely you have to use some kind of external devices, right? Those external devices can be a kind of data keyboards, right? Or some situations where you have to give some kind of mouse. Through mouse also can you give the input or not? Selecting the data like that, mouse, or some kind of hard disk, all those things, right? So can these external devices can connect to the hardware of the system directly? Have you got any question, or is it possible to connect them directly? Definitely not. Why? For example, when you put some kind of pen drive, something like that, what the operating system will do? Operating system will try to install some softwares, what we call drivers, right? So if you buy some new mouse, when you try to plug it, it won't work directly. You have to install some kind of mouse drivers. Similarly, if you want to connect to with some Wi-Fi, some compulsory required Wi-Fi drivers, right? So means if you want to work with hardware of the system, if you want to communicate with the hardware of the system, definitely you require what? Drivers. which acts as a medium between hardware of the system and the operating system. Driver acts as a medium between the user and the hardware. User and the hardware, right? So, fine. So, what are the devices that will be comes under that will use the drivers in general? What are devices that use the drivers? All kind of external devices. All kind of external devices definitely use drivers, whether we know it or not. Indirectly, operating system will can able to understand, right? So, in general, the devices which are used by the drivers, the devices which uses the drivers will be broadly classified into two types, right? Which means whatever the device that are using the drivers, they are generally classified into two types. One will be character devices, another one will be block devices. Character devices and the block devices, right? So let me say a simple example so that you can get clear idea. Character devices are something like keyboards, mouse, etc. And block devices are nothing but like hard disk, SSD, etc. This will become under block device, right? So character device means basically why we are using these devices. We are going to connect them externally because to transfer certain data in order to perform IO operations. So IO operation is nothing but read or write operation, right? So how this character device will perform read or write means how we are going to transfer the data, right? Here the transfer the data is going to be done based on character by character. That's it. Character by character, right? So when you are trying to use any kind of character device like keyboards or mouse like that, the data is going to be transferred in the form of character by character. Whereas coming to go with the block devices, the data which we are trying to transfer from output to like external to system or system to external, the data is going to be transferred in the form of block by block. Means read or write operations are going to be done in the form of block by block, right? So typically in the form of 512 bytes or more than that, minimum 512 bytes, or it can have larger size. Every block size will be minimum 512 bytes. That is what this means, right? So if I say if you are trying to transfer data in the form of character by character, we don't need any kind of storage mechanism, right? So I can say that character devices doesn't require to store the data. It will simply send the data whenever user presses a key. Once he presses the key, it will automatically send it to the system. That's it. But when you go with the block devices, as the data is very huge, definitely you require certain kind of storage mechanism, right? Certain situations it might use buffering and caching also. So based on that, I can say that block devices supports buffering and caching, whereas character devices doesn't support buffering. Okay, now fine. So these are the two types of devices that we understood now. Then how these two devices will work with the operating system? We got the idea that what are the various kind of external devices that will be comes under character devices, and what are the various kind of external devices that will be comes under block devices. Now the next question is how operating system will manage these two kind of devices. Based on what? If I have a system and assume that I have a one external device called character device called keyboard. If you want to connect to this one, right? So we think that drivers are needed, but in general, operating system contains streams and device switching tables are there. These two will manage various kind of external devices, right? So if you are a Navi user, like if you don't have any knowledge, when you if you want to connect to the Wi-Fi, what you thought? Simply you required some kind of driver. What is that? Wi-Fi driver. But in general, if you take more in depth about it, in general, operating system requires streams and device switching tables in order to work with any kind of external devices, right? This internally contains what? Drivers, right? If you look into the structure of streams, the last part will be the driver. This is what that will be communicated to the hardware. Before that, here we are going to have various kind of modules, or I can say that various kind of processing components, and this is what we call it as entry point, where all the connections are going to be maintained, right? With this particular structure, can you observe how, like, this will be connected with what now? External device, right? So now tell me, external devices are going to communicate with the hardware of the system using what? Not the drivers, using the concept of streams and device switching tables. Mainly here streams internally use the device switching tables again. Okay, now fine. So if I say, if any kind of character device is connected, how the information is going to flow? In the form of character by character. If any kind of block device is connected, how the information is going to be flown? In the form of block by block, right? So okay, how many kind of external device will be there for a system? How many external device will be there? Many. As many ports are sufficient for us, that many number of external device might be there, right? Then how it is going to maintain? By using switching tables, right? What is the meaning of a stream here? Flow of data. Streams are going to just establish the connection. Streams are going to just establish the logical connection. I can write here. It's going to just establish logical connection between the external device. I can call it as user process again. User process and the device, right? So, and any kind of external device. Streams are going to just establish one kind of connection between the external device and the process what you are trying to. Process means what here again? A kind of a file only. A kind of a, right? So if only one external device will be there, that is, there is no need of any kind of device switching tables. But in general, we are going to have more number of device switching tables, right? Which means that I can say for the character devices, we are going to have character device switching tables, and for the block devices, block device switching tables are going to be maintained. Right? Again, what is the need of it? Right? So it's a kind of a table. Which contains all the information. What is the information? What is the external device connected? What is the external device ID? And what is its respective driver? Like that, it's going to maintain the entire information. Right? What, like if I say keyboard is connected and mouse is connected, then it's going to maintain what is the keyboard mouse ID, like how it is identified. Based on that, it is going to write the number and what is the respective driver. What is the mouse ID and what is the respective driver, right? So if the table which will maintain the related information like what is the device ID connected and what is the respective driver, that table we call it as character device switching table. The same similarly, if it contains a block device ID and its respective driver, I can call it as a block device switching tables, right? So once you got that, based on that, it will definitely connect it to hardware of the system, right? So then what will be the difference between these two character device switching tables and block device switching tables? One will maintain information about all the character devices, another will maintain the information about the all the block devices, right? What will be the difference between the character devices and block devices? One will be transfer data in the form of character by character. This will transfer data in the form of block by block, right? What will be the examples of character devices? Keyboard, mouse, anything which not store any data. Anything which will not store any data, that will become under character devices. If anything which will store the data, like printer. Printer, does it require buffer or not? Yes or no? It requires buffer because there will be many persons that will be connected. After completion of one person, then only remaining will be executed, right? So definitely they have to store certain thing. That is the reason they will comes under block devices.